Hi guys, it's time for your Friday video. So the first slide we're going to look at in a second is just a review of working another exponential function. And then we're going to talk about graphing systems of equations. So let's see if we can figure out a way to share the screen. Okay, let's see if it's going to work. There it is. Yay, maybe. We'll see. Okay. So the first one we're going to work is a problem kind of similar to one of your homework problems. So look what it says. The population P, so they're calling the variable P the population of a city, is given by this model. P equals 240,360 times e raised to the 0.012t. Now remember, anytime on these videos, kind of stop and take notes as you need to. When where t represents the year with t equal to 0 corresponding to the year 2010. Then it says use the model to predict the year in which the population will reach 300,000. All right, so does everybody understand that this is our model right here? So this equation is our model. And this t in our model stands for our time in the years. And then this P stands for how many people are in the city. Okay, so it says use the model to predict the year in which the population will reach 300,000. So here's my formula. Now, is the 300,000 the P or the T? It says the population will reach 300,000, and population is P. All right, so I put 300,000 in place of P. So I have 300,000 is that 240,360 e to the 0.012. That's a little hard to read, times t. So remember, step one is you have to isolate the variable. So I've got to get this e raised to this power by itself. So I've got to get rid of that really long number. So remember, that number is multiplied by this thing. So we undo multiplication by dividing. So I divided this side by 240,360 and divided that side by the same number. So you know that means that one and that one are going to divide out. And that's just going to leave me e to the 0.012t on this side. And I took the calculator and just said 300,000 divided by that number. And that's what was on my screen. Okay, so now my variable's isolated. So remember, once that variable's isolated, take the natural log of both sides. So I did. All right, now remember, with natural log, you can take that and pull it down front by that third rule that we went over. All right, so I took that and I pulled it down front. All right, so that's what this is right here in the parenthesis. All right, that was my power. And I pulled it down in front of the natural log of e. All right, and then I just left that kind of the way it was for a second. Remember, the natural log of e is just 1. You can punch it in your calculator and get that. So I need to get rid of, I want to solve for t, so I've got to get rid of that 0.012. So I divide this side by 0.012, and I'm going to divide this side by 0.012. Now, this long decimal number is what I got when I just typed in the natural log of that 1.248127808. So the natural log of that number was that number, and then both sides got divided by the number in front of t. So that said t is about this number, so t is about 18. But now it didn't want to know how long, how many years. It wanted to know the year, the actual year. So remember what it says, t equals 0 is the year 2010. So what would 18 years later be? I'd have to add 18 to my 2010 and come out, it'll be the year 2028 when that happens. Okay, so on your homework, double check to see if you're substituting for this number or you're substituting for a number over here. So just make sure that you're clear about what you're substituting. All right, now let's go talk about systems of equations. Now, you know how to solve just one equation. A system of equations means that you have more than one. Okay, like what we're going to talk about is a system with 2 equations in it, but you can have a system with like 3 or 23. But we're going to just do systems of 2 equations. Okay, so when you have systems of 2 equations, that means you want to know all the numbers for x and y that will make both of these true at the same time. So for instance, if x is 1 and y is 3, all right, suppose x was 1 and y was 3. Okay, now notice that if you substitute in that first equation, sure enough, let's try to make it visible. 1 plus 3 is 4. But if you put that down here, 1 minus 3, though, is not 2. 1 minus 3 would be a negative 2. So this is not a solution to the system, okay? Because for it to be a solution to the system, it's got to make all the equations true at the same time, okay? So that's what we're going to look for. We're going to do it 2 different ways. We're going to do it in this video by substitution. In class Monday, we're going to do it by something called elimination, okay? So look what it says. It says you solve for one variable in one of your equations in terms of the other variable. All right. Then you substitute the expression from step 1 into the other equation and solve it. And then you substitute that answer back into an equation to get the other variable and you check. Now, what's that talking about? Now, how do you know? I'm going to either make this one say X equals or Y equals. And it's really just your choice. You're going to get the right answer either way. You're going to get the same answer either way. So I arbitrarily decided that I was going to make this one say Y equals. So how would you get rid of that X? Because it's added, you're going to subtract it. So if I subtract X from both sides, won't these X's go away? And that's just going to leave me Y. And then I have 4 minus X. So Y is the same thing as 4 minus X. So because I used equation 1 and solve, that's what it means by solve for one variable in terms of the other variable. So you're going to have one letter by itself equal some other stuff. Then go to your other equation and substitute in. So wherever there's a Y, I'm going to put in 4 minus X. So here's my second equation. X minus Y is 2. So wherever there's a Y, I'm going to put 4 minus X. So there's my X, there's my minus, oops, it says Y. So in place of Y, I put 4 minus X. And make sure you put it in a parenthesis, okay? Equals 2. So all I did was put 4 minus X in place of Y in this equation. So that's going to be X minus 4, and then minus this negative is going to be plus X. Well, then I can combine like terms. An X plus another X is a 2X, but I've still got this minus 4. So 2X minus 4 is 2. So we're just going to solve this equation. So I added 4 to both sides to get rid of that minus 4. So that goes out and just leaves me 2X. Then, of course, 2 plus 4 is 6. Then if I want to solve for X, I've got to get rid of that 2. So I divided both sides by 2. All right. And when I divided both sides by 2, I can't read my own writing. All right. So I'm dividing both sides by 2. Then X comes out to be 3. Okay, so I get X is 3. Now, let me show you what I did. All right, now let me show you something. All right, let me kind of clear this and make a point. All right, I want you to notice that I've made a mistake. All right, now this is going to work out really well for me. All right, I wasn't paying attention and I divided both sides by 3 and I got X to be 2. Now, we're going to fix this in a minute because this isn't right. I shouldn't divide it by 3. I should divide it by 2, but I wasn't paying attention. So I got X to be 2. Now, how do you get the other one? You plug back into this. Y is 4 minus X. So 4 minus, if I put 2 in there, I get 2. Now, look what happens when I plug these answers back. See, I didn't do step 5. If I do step 5, it helps me catch mistakes like this. Because watch what would happen. If I put X to be 2 and Y to be 2 in here, I do get 2 plus 2 is 4. Okay, so that means that made the first equation work. So that would have worked, check. But look what would happen right here. If I put 2 in for X and 2 in for Y, 2 minus 2 is 0, and 0 is not equal to 2. So it wouldn't work here. So that's how I would know that I've made a mistake. Okay, so if you check it, you can catch your mistake. So let's go fix it. All right, so it should be right here, instead of dividing both sides by, I should have divided both sides by 2. All right, which means that X should be 3. All right, so I know X is 3. Now, how do I find Y? Well, you can plug into this equation or this equation or this. You can plug into any equation and find out what Y is. This is probably the quickest one though. y is 4 minus x. So we found out our x was 3. So 4 minus 3 is 1. So y is 1. So this is my answer. My answer is x is 3 and y is 1. Okay, so let's go double check it. 3 plus 1 is indeed 4. All right, and 3 minus 1 is indeed 2. So when x is 3 and y is 1, it makes both of these equations true. Now, let me tell you something very interesting, and we're going to do this on Monday. If you graph this equation, they're going to graph a line. And if you graph this equation, you're going to graph a different line. And those two lines are going to intersect at the point 3, 1. All right, so when x is 3, y is 1. So if you were to graph both of those lines, they would cross right at the point 3, 1. So 3, 1 is a point on that line, and 3, 1 is a point on that line. So you can write your answer as a point, or you can write it as x equals 3 and y equals 1. Okay, so let's go work another one and make sure that we're good before you start trying your homework. All right, look at this one. All right, here's my equation this time. All right, so I've got x minus 2y is a negative 2, and I've got 3x minus y is 6. So again, it doesn't matter which equation you use. You can use either one, but just solve for one. So do you see how this would be easier to make it say x equals than it would be to make it say y equals? So do whichever one's easiest. So I'm going to make this say x equals. So to get rid of that minus 2y, I've got to add 2y to both sides. So remember that minus 2y plus 2y goes out and leaves me x. And so I'll get x as a negative 2 plus 2y. So that's what that meant by solve for one variable in terms of the other variable. So if you use step 1 to do this, now you're going to, equation 1, now you're going to use the other equation. So equation 2, 3x minus y equals 6. So every time I see an x, I'm going to put in negative 2 plus 2y. So there's a 3. Oops, there's an x right there. So in place of that x, I put negative 2 plus 2y. And again, make sure you always put it in a parenthesis. All right, I've still got this minus y, so I still have to put minus y. I've still got this equals 6, so I've got to put equals 6. Then I just solve this equation. So distributive property of multiplication over addition. So 3 times that 2 is going to give me negative 2 is going to give me a negative 6. And then 3 times this 2y gives me 6y. But then I've still got this minus y equals 6. So I've got a negative 6. Now what's 6y minus 1y? Isn't that 5y? So I've got to solve for my variable. So how do I get rid of a negative 6? Couldn't I add positive 6 to both sides? Because a negative 6 plus a positive 6 is 0, and that leaves me just 5y. And then, of course, 6 plus 6 is 12. So to get rid of that 5, I divided both sides by 5, and y came out to be 12/5. Okay, so I think y is 12/5. Now, how do I find the x part? Go back over here and substitute in. Put for that y right there, I'm going to put 12/5. So I've got x is a negative 2 plus 2y. So in place of that y, there's my 12/5. Well, 2 times 12/5 is 24/5. Now think about why. Can't whole numbers go over 1? And 12 times 2 is 24, and 1 times 5 is 5. Then I had to get a common denominator. Now again, that's like over 1. So we're just adding fractions. So my common denominator was 5. So what do you multiply 1 by to get 5? Isn't that 5? So you've got to take your old numerator, negative 2, and multiply by 5 and get negative 10. So a negative 2 is just a negative 10 over 5 because I need a common denominator. And remember, when the signs are different, you subtract. So 24 minus 10 is going to give me 14. So x came out to be 14/5. Now, because I made a mistake on the first one, I'm not going to forget step 5 on this one. I'm going to check it and make sure that it works. So in both of these equations, I'm going to plug in y is 12/5 and x is 14/5 and make sure that it gives me a true sentence. So x, remember x was 14/5, so I put 14/5 minus 2, and then y was 12/5. Well, 2 times 12/5 is going to be my 24/5. So I've got 14/5 minus 24/5. So I keep my common denominator, and 14 minus 24 is a negative 10. A negative 10 divided by 5 is indeed a negative 2. And it does check, negative 2 equals negative 2. So that one worked. So let's use the second equation up here. So for x, I'm going to put in my 14/5, and for y, I'm going to put in my 12/5. So for x, I put in that 14/5. For y, I put in that 12/5. Remember, that's like 3 over 1. Well, 3 times 14, you can use your calculator, gives you 42, and 1 times 5 is 5. So I get 42/5 minus 12/5. Well, my common denominator, I've already got it, so that's good. And 42 minus 12 is 30. And sure enough, 30 divided by 5 is 6. So 6 equals 6, check. So I know I'm right, okay? So on the homework, when you're solving your systems of equations, take one of your equations, it doesn't matter which one, whichever one's the easiest, and make it say one of your letters equals everything else. Then go to your other equation and substitute this in for this letter and just solve it. And that'll get you one answer. Then to get your other part of your answer, you plug back into an equation. All right, this one's usually the easiest to plug back into. And then double check, put both of those values in both equations and make sure that you get 2 true sentences. Now, like before, we're going to graph some of this on Monday. If you were to graph this line and this line, they're going to cross at the point 14/5, comma 12/5. So 14/5, remember, that would be about 2 4/5, so about 2.8. And this is 12, so this would be about 2 2/5, or about 2.4. So you can either box both of these, or you can write your answer as a point. That's completely up to you. So try your homework and let me know if you have any trouble with it. And then on Monday, we'll work it a different way. We're going to do it what's called by process of elimination. All right. So that way you can do it whichever way you want to. Okay. Hope you have a great weekend. Bye.